All right, everybody. So, sorry I couldn't be there today. Most of this practice you're going to get is going to be from those practice problems that Ms. Irvine's going to direct you to. But just a reminder of how to solve a specific kind of proportion. I also remind you on the next quiz, there's going to be problems that, like, I might say. Oh wait, I'll only give you one of these lines, but I would say, like, dilate this shape by k of 1/2, okay? And you would have to use a ruler and do what we did on day one. The other thing that I want to remind you of is if I give you something that's already dilated, and this probably won't work out, and I ask you where the center of dilation, remember the center of dilation comes from where if you connect the points, all the points line up from a central point. So if you just connect all the points, you're going to find where they intersect is the center of dilation. Please also remember, if you ever want to know the scale factor, I could do one of two things. So if, like, the distance from here to here was A, and let's say this was the new one, and the distance from the center of dilation to there is B, remember, if you do the new distance divided by the old distance, that will get you the scale factor. Or you could also just measure the lines that go together, and you could do this new line divided by this new line. You should get the same answer either way. Reminder about solving proportions, but sometimes you're going to get, I'm just trying to think of the hardest kind of proportion you would get on this practice sheet, and it might be something like this. 9, 3. So as a reminder, you do cross multiply and you get 27, and that's going to equal the cross multiple of this. As a reminder, when you multiply x plus 3 times x plus 2, you don't just multiply the first numbers and the last numbers. You have to remember, distribute both of them, the x and the 3, to both things. You might have learned this last year as FOIL. I don't really love calling it FOIL, but it was like front, inside, outside, and the last terms. But I just like to draw like a little line from the x and a little line from the 3. X times x is x squared. X times 2 is plus 2x. 3 times x is 3x. And 3 times 2 is plus 6. And then you would combine and you would get x squared plus 5x plus 6. Remember, when you have a quadratic and there is another x, you can't just do the square root method. You then would have to get this equal to 0, so I'd subtract 27 on both sides. And when you subtract 27, you would get negative 21. I think I did that right. Yep. Okay. And then at this point, you could use factoring. But, in Algebra 2, you're going to have to remember how to factor. But in geometry, your job is to just find out what x is. So please feel free to use the quadratic formula. But when you use the quadratic formula, please remember that the first thing you want to do is the b squared. Oh, no, you don't want to do that first. You want to do negative 4 times a times c. Now, sometimes negative 4 times a times c will get you a positive answer. So then it's going to turn into b squared plus whatever you get. And sometimes you're going to get a negative answer, so it's just minus whatever you get. And trying to think if there's anything else. Oh, yes. For that quiz on Friday, please remember that we can use proportions to solve things that are in the same ratio or scaled. So just as a reminder of one of the problems we talked about, but I'm going to make it a little simpler. I'm going to say, like, if a 6-foot person has a 1.5 inch shadow, so this is the person, this is the shadow, and there's a second person, and you know that their shadow was 1.75 inches long, and you want to know how tall they were, you want to set up a proportion. But when you set up your proportion, there's many ways you could have done it. I'm going to call this h for the height of the person. So I could do a proportion that goes 6 is to h, because that's like basically I'm just doing the heights on this side. And that means that you're going to do their shadows on this side, but the shadow for the 6-foot person must be on the top. So that would be h. Oh, no, kidding. That person's shadow was 1.5, and the new person shadow was 1.75. But remember, you could also have done it h over 6. And you just would have to make sure that the shadows match up with the correct person. you don't even have to do it this way. If I, instead of doing height to height, I wanted to do the height and shadow of one person, that's fine as long as you do the height and shadow of the other person. So that would be a 6-foot person over a, which is the shadow I don't know. Oh, I did that again. A 6-foot person had a shadow of 1.5. A person's height who I didn't know had a shadow of 1.75. Might have made that person too tall in this example, but I don't think I did. Well, they're going to be very tall. But anywho, that's just the idea that you could write a proportion different way as long as you keep either these things have to match up and these things kind of have to match up in category. So this was person's height to shadow, person's height to shadow. And this was the shorter person, this is going to be the taller person. So everything kind of has to match up. All right? So make sure you get some practice using the screen that your teacher is going to tell you about, and then I will see you on Monday.